Okay, so welcome to this lecture about statistical aids to hypothesis testing. So this is one out of four lectures about this topic. So the first topic will tackle about the introduction to the Z and the T test. And then the other lectures will focus about examples of T test and F test as well as Q test. So kung napansin nyo sa experiment 1 nyo ay meron ng Q test because it's a statistical method uh, meant to accept or reject certain data in your own data sets. While the ones that we will discuss right now, the Z test and T test, is about a comparison of your data set with the different data. So now we will start with defining the formula for the Z and the T test. So these two formulas have almost the same structure, so which is x bar minus mu naught over sigma over square root of n. So, ang pinagkaiba lang ng dalawang formula na to is your Z test has sigma and your T test has S. So, to start off, so yung S mo is your sample standard deviation, while your sigma is your population standard deviation. And then, your X bar is your sample mean, and then your mu naught is your accepted value, and then your n is your number of observations. So, if we will again go back to your experiment number 1, so meron akong question doon na uh, if the correct value for your for the weight of your coin is something like 10 point something. So doon papasok tong mu naught kasi meron kang reference value. So parang ito yung reference value, ito yung acceptance. So halimbawa, kung nag-test ka ng COVID, so meron ka bang reference value for the amount of the viral RNA na pwede mong gamitin para i-accept or reject yung hypothesis mo. Kasi yung hypothesis mo dun is meron bang COVID yung patient or wala. So, dahil nasabi ko na yung hypothesis, so pasok tayo dun sa topic ng hypothesis testing. So, hypothesis testing ay ito lang yung kapag kasi nag-measure ka, so pagka nag-measure ka lang, ano ba tong value na to? Ano bang relevance ng value na to kung hindi siya relative to another? So yung hypothesis testing is you are comparing your value to another. In this case, in this first example, first encounter, it's relative to an accepted value which is your mu naught. So your null hypothesis, so sinasabi lang ng null hypothesis na yung iyong so represented as H naught, your population mean. So mu is your population mean. Population mean. Yes. So it's equal to your accepted value. Ibig sabihin, walang pinagkaiba. So kung halimbawa dun sa experiment niyo sa weighing sa coins, so pwede kayong gumamit ng Z or T test para malaman kung different ba yung values na nakuha sa tatlong analysis, sa tatlong weighing balances. So you will treat that as one analysis. And then you have your alternative hypothesis. So alternative hypothesis is when your mu is not equal to mu naught. So ito yung una, reject H naught if Z is greater than or equal to secret, or if z is less than or equal to negative secret. So this should be negative. Okay. So, saan pa makukuha itong z critical na to? So, meron kasi tayong tinatawag na table. So, ito yung T-table. So, meron siyang dalawang axis. So, ito ay nagko-contain ng confidence interval. So, confidence, percent confidence, and then you have your degrees of freedom. So, yung degrees of freedom, so it's the number of observations minus 1. So, n minus 1. So, itong table na to, so may nagko-correspond the value sa intersection ng degrees of freedom and percent confidence. So, yan, may 1, 2, 3, etc., etc. And then, you will have values here, specific values. And then, so what are these values representing? So, meron tayo dito sa taas. So, this is your Gaussian curve. So, ang Gaussian curve ay nagre-represent ng probabilities. So, this is your z value. Ayan. So, probabilities of an event occurring. So, ang area nitong Gaussian curve, so event space, happens in the set of real numbers. So, real numbers, so pwedeng negative, pwedeng positive, but hindi pwede yung mga non-real numbers. So, dito sa Gaussian curve, meron kang peak, which is your mean. Yes. So dun sa gitna, yung peak ay meron kang mean, and then equally distributed sa magkabilang side. Yan. So, para siyang bell shape. So, it goes down, and then dapat symmetric. So, imagine nyo na lang na pantay yung drawing ko sa left and right. So, ang makukuha nyo dito ng lesson is that as you go farther away from the mean, so mas bumababa yung probability na makukuha nyo yung value na yun. So halimbawa sa measurement, so meron kang mean dun sa weighing. So halimbawa may mean ka na 10.05. So as you go away from the mean, mas bumababa yung chance na makukuha mo yung 10.05. So for example, this is 12. This is 8. So, bumababa yung probability. So, ito yung pinakamataas na probability density. So, okay, sana na-gets nyo. So, itong values na to, so, halimbawa, at 95% confidence interval, and then at infinite number of degrees of freedom, so meron ka z value of 1.96. So, paano ba natin ito i-represent in the graph? So, meron ka ditong value na, let's represent this as 1, 2, 3, 3, 3, 2, 1. Yeah. So halimbawa, ganito yung representation mo. So, at the value of 1.96, so which is estimated to be this and this. So, lahat ng values, pagka sumobra na yung value mo, so z is greater than z critical. So, ito yon pag sumobra na sa 1.96, and then pag yung z is less than or equal to negative secret, so itong kabila, so pwede mo na i-reject yung null hypothesis. Ibig sabihin, hindi na magkamukha yung mu tsaka yung mu naught. Hindi na magkamukha yung, hindi na agree yung value mo sa known or accepted value. So, this is at 95% confidence interval. So kapag halimbawa, nasa 99% confidence interval ka na, so mas liliit pa yung yung region na masasakop. So depende yon dun sa makikita mong value dun sa T table. So yun yung graphical representation ng acceptance or rejection ng values. So itong pinakita ko po na example is an example of two-tailed t-test. So, bakit nasabing two-tailed? Kasi itong dalawa na to, so this is represented as tails. So, kapag ito ay nagko-correspond sa regions of low probability. So, kapag kasi statistical analysis ka, so para ma-reject is kailangan talaga magkaiba sila. So, nandun sila sa region of low probability. So, ngayon, hindi siya useful kapag pagka ikaw ay nag-conclude, halimbawa, na it's just not equal. So, meron ka din single-tailed t-test. So, H sub A, mu is greater than mu naught, so higher than your known or accepted value. So, reject H naught if Z is greater than or equal to Z3. So, ito yon. Ito yung region na yon. So, pwede ka na agad makapag-conclude, halimbawa din sa data ng balances. So, kapag ka nag-perform ka ng t-test, pwede mo na makonclude na mas mataas yung binibigay na value ni top loading balance kaysa kaya analytical balance. Kung if the Z value is greater than or equal to Z3. So, pwede nyo matanong kung bakit Z lang yung nakalagay dito. So, pwede mo rin naman kasi gamitin dito yung T kapag ka ang N, itong number of observations mo ay mababa. So, technically, if you want to use t-test on your balances, so you need to use T. So, you can just replace Z with T. So, T is greater than or equal to T3. So kaya ko siya pinagsama sa isang video lecture. And then, if your alternative hypothesis is mu is less than mu naught, reject H naught if Z is less than Z3. Yan. So tatandaan niyo lang sa hypothesis testing is, sa hypothesis testing, pinoprove mo lang kung bang significantly different yung value na nakuha mo sa isang value. So, in this lesson, it is a reference value. So, kapag lumagpas na siya dun sa critical values, so dun mo lang masasabi na siya ay significantly different based on the degrees of freedom. So, degrees of freedom is n-1. So, kung sa balances, ang degrees of freedom mo ay 9 kasi 10 minus 1. So, kailangan mo lang hanapin. So, at ilang percent po ba gusto? So, halimbawa, gusto mo at 99%. So, hanapin mo lang yung value corresponding to the correct degrees of freedom. So, syempre, habang tumataas yung percent confidence mo, mas mahirap i-achieve yung mas mahirap i-achieve tong mga alternative hypothesis na to. So that ends this lecture. Thank you for listening.